All right, welcome everyone to another community meetup regarding cross-platform development. Today we're going to be discussing full text search capability in .NET and in SAP with Ms. Josh Ojeda. Josh, I'm going to let you introduce yourself and then we'll go from there.
Hi everyone, my name is Josh Ojeda. I work for Sari and Bit Frameworks. I'm a DevExpress MVP, and usually I'm in search of research and development in our company. So in this case, I'm going to present how you should integrate full text search into your .NET application. In this case, the presentation says SAF, but it's also good because it's something that you will use in the backend mostly.
Perfect. I'm really excited to see this talk. So a few comments on before we start. NetConf 2023 is coming now in November, so keep tuned for that. And our next meetup, we will have Michael Washington talking about Azure Open API. So I'm gonna also give the link from his new book that is already on Amazon. That is a really good book to have if you want to know about everything that is happening today in the AI world. All right, Joshi, take it from there and let's get started.
Okay, so this is one of the strange cases where we have a presentation. Usually I go straight to code, but we need a little bit of context for this. So I'm sharing my screen. I don't know if you can see it already.
Yeah, we can.
Okay, so in this presentation, we're going to see like a few concepts about full text search and how you integrate that in your .NET application and the different flavors that is possible to have. So first, the agenda for today is, first point is to understand what full text search is, what are the benefits, and then how you can implement it using different technologies. In this case, we're going to have two examples. One is using Apache Elasticsearch, and the second one is using Postgres vector search. And this is mostly a backend thing, so almost the UI is not important for this case. It's about to understand how you can use this and what are the benefits in general. Okay, so the first thing that we need to understand is what is full text search. Basically, it's a technique to search collections of documents or database tables that contains specific words or set of keywords. So that is a little bit different to a normal SQL query, where in an SQL query, you have you run it over just one column, and you have some text operator like and things like that, start with, end with. But this is a little bit more complex in the sense that you give context to your search parameters. So it's a little bit different. And also, one other difference between full text search and a normal SQL query is that in full text search, you have indexing of the objects that also exists in the database level, but it's a little bit different in the sense that it's kept on memory. That's why it's really fast. So if you want to implement your own full text search server, whatever flavor you use, in a lot of cases you will end up using a lot of RAM, but it's good because you want your search to be really fast, and you don't want to hit your transactional database. So that's why it's kind of good to take your application to the next level and implement something like full text search. There is also one other thing that is important here, is that since you have, since you can put a context on your search terms, that context will depend also on your language, and will find results like what you're looking for. So that's another interesting thing, that you are not, usually you're not able to get something like that with an SQL query, or can be a really complex query if you're able to get that. So the key characteristics of full text search is, we have a few of them, and I'm talking here in general, but most of these characteristics are implemented by several different engines. So then you have to pick your own engine and decide for which reason you want this or that one. So the first characteristic is indexing. Every time that you create a document or you create an index record, it automatically starts and decide where to put it on the list, if it's in the top, if it's in the middle, if it's in the bottom, because these operations are in memory. So they are really, really fast, and they happen in real time. So you don't have to re-index your database later or create a process to rebuild the indexes. The second key feature is ranking. So as if you ever use Google, and I guess everyone has used Google before, whenever you search something, the search results are the first one that you have in the top is the one that is most likely to have what you're searching for. And I don't know if you remember this screen on Google that says search, and then the next button say something like I'm lucky today or something like that, which it means that will bring you to the first result of the list, because that's the most likely to match whatever search parameters you put. So ranking is really important, because this is not like kind of exact query, it's non-deterministic. So it's like the likelihood to be whatever you want to match. So it's important to see the ranking. The third one is advanced query capabilities. Even though this is super important, is you kind of never use them in reality, because for example, in Google, you can say something like, look for mobile development articles, not Xamarin. You can invert the results, say like not within and things like that. So even though they're not common for people to use them because you want to use natural language, they are also available. So you can use Boolean operators, wildcards like asterisk to replace some part of the word, phrase searches, and proximity search. That is something that is really interesting, that you want to see how close is this result to this other result. Basically, you create a set of nodes, and then you tell something like, I want the distance, I want something that is 3 nodes on the side of these results. You can use that in social network engines to say something like, give me the people that you might know, because I'm getting the people that your friends, your direct friends know. So this is a really interesting topic for proximity search. And let's see, what else do we have? Stemming and lemmatization. This one is interesting. It's also related to the natural language processing, which is how the queries are being parsed or how they are understood. In this case, what is important to know is that since you have natural language processing, that your results are defined in a specific language. So for example, you can put a search term, create an index, and say that this search term and this index is in English, or this is in Spanish from El Salvador, Spanish from Cuba, Spanish from Mexico, Spanish from Spain. Because some words will be treated differently depending on the language. And in every case, you will have different combinations of or permutations of the word. For example, if you're looking for the word run, you also might find running, which is not exact run, but it's a related word. So this is really interesting. This is how ChatGPT works. And well, then you have different set of features that it will depend on your engine. For example, Apache Elasticsearch is mostly in memory, and Postgres is on disk. So there you have some differences on your implementation. So before I move forward, I want to present the problem, the technical problem, and then we will go back to the presentation and see the possible technical solutions. So before I move forward, I'm going to show you an all prototype that we have, because in general, you want to create some search functionality in your application for your customers. So this was one idea that we have in the past, which is a really good idea, I think, but it's really costly at the database level. So the idea in this case was, we have this application. This is a XAF application, but since most of this happen in the backend, it's okay to show it in any type of technology. So the idea here was, we have our entities, and our entities are decorated with an attribute that we call full text search or universal search in this case. We have different attributes for different type of search. So it means that whenever I run a search, this entity will be included. And then you have how you want to format the results. You have a format string, and you're telling it which columns you want to use for search. So it's really interesting how easy can you add this to add search functionality for your entities. The thing is that it's going to be really database heavy. So, okay, we have two entities decorated so far. We have products and city. Let me run this one, and I will show you the queries that it creates. And then we will do the same with Elasticsearch and see what different, how it can be different in general. So let's wait a little bit for this to run. And in the meantime, if there is any query, because this takes some time to build, if there is any questions, sorry, query, I'm talking about database things now. You can just write it in the chat. And if I have the answer right now, I will just answer in live. If not, I will come back to you in an email or something. Okay. Something else is running. Beautiful. So let's run this again. You know, the demo effect. But I did this conference earlier today, so everything that exploded there is already fixed. And well, in the meantime, if you want to see how an Apache Elasticsearch server looks like, it looks like this. Kind of really ugly. It's a console program that you run, and that case I'm in memory database. So I will talk about this a little bit later. But I turned on this a few minutes early because it takes time for it to start. So I turned it on before the stand-up. Let's wait a little bit for this, because since I'm sharing in Zoom, sometimes web applications takes really long time to load. This is usually faster if I'm not sharing.
In the meantime, I can share one of our, we have a client that he did a project that basically, because he was using Azure, and if he was using the database on the Azure side, he was able to use Azure Search to search anything in the whole database real fast and just return the unique identifier to the application. That way, the application, the only thing that it has to do is take that unique identifier with the entity type and load that entity. But all the search and everything else was happening on Azure Search on the backend. So it did definitely make a million records query in the Azure side, and in your side, you only get one OID, one entity type, and loaded really,
And then you do
fast.
the
So
real query, right?
Exactly.
I mean, I think that's actually the next level in general is that when we build the application, we do everything by queries. Like, okay, this will be how the application search. But in general, I think that you cannot ask so much things to your transactional database. We want like one simple solution that one technology do everything for us. And sometimes you need to add something like this. That's how social networks work, basically. They have like or also Amazon is kind of the same. You're always searching in the Elasticsearch level. And then once you click the record, then you see the real query to the database. Okay, so let's put this here on the side. And this one here. That's it. So what I want to show you is the output of this. So if we check, we have cities, like a list of cities, and then we have customers, which is not included right now in the search. And then we have products. Okay, so we can clear all of this. And we can go to the universal search. This was our first prototype using database queries. So let me clear the console. And let me search for the words Ita, like from Italy. Just a partial word. Okay, so here is the interesting part. In this case, the first queries that you will see here in the screen are about the security of this type of application. But then you will see the queries that are being constructed. For example, this one is the query that will run over country. So you're looking at like you're using the contains operator. And the same goes for the category. Here you have the operators. So the more objects that you have listed in your universal search, the more queries that you will do. If you have 10 objects, you will have to do 10 queries. And then out of those 10 queries, you need to actually query the exact record that you're going to use and retrieve it. For example, here we have the queries. These two queries that we saw here are the queries that created this search result. So we have one city and two products. If I clear this and if I click on city, this is the real query to get the city. So this is what we're avoiding right now. Like we're not executing the query for the real record, but we're executing the search queries before. And at this moment, we're using the capabilities for ORM, or this is SQL Server from Microsoft. So we're doing like regular queries to get the results. So that's what I wanted to show you. That is kind of the traditional way. And that's the problem that we're kind of fixing at this moment. So we're not going to use this solution anymore. I just wanted to show you the queries and the idea of a search engine inside of your application. So let's go back to the PowerPoint for 1 second. I don't know why I always start in the first slide, but okay. So what we're going to do is whatever we saw before, the example that we were using database queries to do the search, we're going to replace it with Apache Elasticsearch. It's going to be the same application, but it's going to do the search in a different way. And just to put everything in context, what is Apache Elasticsearch? Basically, it's a distributed open source engine. You can get it in several ways. There are like hosted services. You can just run it yourself if you have a Linux server or a Windows server. This requires kind of a lot of memory because the database is kept on memory. So that's kind of good because it's really, really fast. It's based on Apache Lucene library. You get basically real-time results. You can, for example, when you use Elasticsearch for using autocomplete in search boxes, that's how they work. They usually search the memory index, and then you're getting the next word. So you can use it for predicting what the next word is going to be on a search query. So then this is what is going to happen. This is the Elasticsearch flow, but it's usually almost every search flow in general. So we have our users. Then you have some type of search UI. Imagine Google that you have only like one text box. Then with those parameters, you build a query, then you run the Elasticsearch. And here you can go into different ways. You can just return the results, render the results in the search UI. And that means that if you do that, you have not hit your database, your transaction database at the moment. You just execute the query, return the results to the user, because they might not even click on any of the results. So why to go to the database and get the data? Or you can run the query, then send the results of the query to your database, and then return the real results. It depends on your use case. Both cases are valid. So let's go back to code. So here we have another implementation of the same idea, but this one will implement the search using Elasticsearch. So for that, we have included a service. First, which NuGet do we use for this? Nest. Nest is the official Elasticsearch client for .NET. And then we just have here like a small extension. The extension, what requires is your password and certificate from the server, and then some configuration about which index are you going to use if you're not going to have, if you don't define the index on your queries, and also where the server is running. This Apache Elasticsearch server is basically an API. So it's running on this URL, and this is the default index that we're going to use. Regarding the indexes can be basically a copy of your model. Let's say that you have a model that is called book, so you can make basically a one-to-one copy to it. And if not, you can create a general index with some keywords like in a huge text, and then you decide what to use, how specific your index should be. So something that we need to get from our server is the login information. So this one is my password. So let's get it from here. Now we need to replace it here because this was the password for the previous demo. And then we need the certificate. So let's change the certificate here. So basically, that's almost everything that we need to add our Elasticsearch client to our .NET application. And after that, you can always just resolve the client out of your services in your application, and then you have the indexing process. So let me show you the indexing process, which is kind of also really simple. There are several ways to introduce this in your application. But in here, since this is a SAP application, I have, well, let's see it in this one, because I have several implementations of this. So here, I'm creating just records in code. Let's see, sample data execute, this one. So as you can see, I get the Elasticsearch client, then I create a set of cities, products, and customers, and then I just added to a list of models. And these models, I use them I save this in the Elasticsearch server. So the model will contain basically a property with all the keywords that I want to save, because you save keywords out of your real model. Like, for example, specific things like color, size, and everything. or you can just make a one-to-one copy of your model, depending on your use case. I like the idea of a general model because you can use it for several different type of data. So you have to save which data type you have and the key of that object. So the model looks something like this. So in the model, we have in this case, the GUID, which is the key of the record that we are looking for. The type name, because we use it to identify the type of entity. I'm using an ORM here. I'm using XPO from Developer Express. The keywords that we're saving, when this was created or updated, beautiful. The studio is is behaving bad. So let me close this. And then you have when this was created or updated, and also an identifier if it's new or not. You use that identifier to know if you're going to create an index or you're going to update an index. Because if you update a record, maybe the keywords change it, and it will be in a different position on the index in memory. So that's basically all that we have on the indexing part. And then on the search part is kind of really simple. What we have here is just, let's see, is this part. We get the Elasticsearch client, and then we search for that specific index model. And then we do a query over it. And in this query is, we have like wildcards at the beginning and in the end. And then we have a specific size of results. You can return up to 5,000 results or as many as you want. And this query can be either really complex or just you put the wildcards at the beginning and the end, and then you pass the search terms, and that's as simple as it can get. So let's run this one. And let's see how it goes. Then we will do a different implementation. The beauty of this type of search is when you have a lot of records, when you have millions of it, then you will see the real difference between searching something using Elasticsearch and searching something using your database. Database will always be slower. Elasticsearch is on memory, so it tends to be way faster. And for example, if your database is, I don't know, less than 100 gigabytes, you can run a Linux server for less than 100 euros that can hold all of that in memory. And of course, what customers always like is speed. So let's see. Let's check the chat. So no questions so far. Let me just move the server because there is no output here. You don't see anything that is happening. Okay, so let's log in here. This is basically the same application as the one that I showed before, but it's an iteration. We replace the universal search that we created by using queries with Elasticsearch. And then we will run the same demo using vector queries. So, okay, we're inside, almost inside. And now we have more sections here. So let's go to the Elasticsearch. But this one, for this one, we need to create the data because this database is empty. So when I create the sample data, I show you that I'm also creating the indexes. So let's run this one. And I think it's done. Let's refresh here. Yeah, we have cities and everything. So you can see the queries here, that everything that we did for the insert. We had some tasty food here, like sushi, fried chicken. It's basically the same data set as before. So in this case, let's go to the Elasticsearch and let's clear the output. And let's search for the same things like Italy. Or we can search for pizza later or Mexico. Okay, so here we have a result set. Basically, we have one city, one customer, and two types of products. They do contain the partial part of the word ita. That's why they did a match. And as you can see here, all these queries that we have here are from the application. It's basically the security system asking, does this person have permission to search or click this action or this button in the UI? But there was no query executed in our database. So far, all of this happened in memory on the Apache web server, on the Elasticsearch server. So we can continue querying, and we will never hit our database. So then your transactional database is getting like offload of that burden of doing the search queries all the time. And if you have a highly concurrent database, maybe you use it for e-commerce. E-commerce is mostly search, and a few times you hit a specific record, and then you do the real query, right? But most of the time, people is just searching. So far here, no queries to our real database, and I'm going to clear the console again. And now, once we hit one of the records, the real query happens. So we're avoiding these queries to happen because this will happen if we search for the real object. So then we're saving memory, speed, and resources from the server. It's good to rely in something extra for the search. And then once we have the real information, we just retrieve that single record in our application, because this is really, really fast. It's a memory database. So that's how easy it is to implement Elasticsearch in our application. You just inject the client, then you spin up a server. Whatever that server is, it can be hosted by you, or you can use any of the services. And then you just create the index for your records, and then you search over those indexes. So it was kind of a really simplistic example, but as a getting started, I think that's the way to go. Okay, so this is one type of search that you can include in your application. This was Elasticsearch, which in the end is something that is called full text search. That exists in different engines. Also, database engines, they do have a full text search functionality. Not all of them are implemented totally different. The one from Postgres is not the same as the one from SQL Server. So we're going back to the PowerPoint for just 1 second.
Okay, just for a second.
Mm-hmm.
All right, so if our Elasticsearch server has a copy of memory of our database, when I'm changing things on the database, how is that get synchronized? How that gets updated?
Well, what you have to do is, if you have Entity Framework or XPO or something like that, on your save event, you should send the index again. Basically, every time that you save an object, you need to send a request. And what will happen is that maybe your index search with the new values, so will be re-indexed on memory also. So you don't have to run a process after you update an index. You just need to make sure to hook up the right parts of your application to start indexing whenever you save a record. And also, if you have an existing application, you need to create a process to go through all those records, like one by one, and save the indexes. And after that, you're kind of good to go. And Apache makes the process of everything is handled on memory. When you shut down your Elasticsearch server, it goes back to disk. Then when you turn it on again, it goes back to memory. So it handles all the process. And you can create also replication, or you can have several Apache Elasticsearch servers working together. So when one is offline, the other one will do the search for you. So there are like kind of really neat scenarios to implement. You just need to know the right places to hook up the indexing events in your application. That's kind of the most important part.
Yeah.
So let's go back here. And let's see if it starts from where I was. Yeah, it's always go back to the beginning for some strange reason. So let's fast forward this. So we have some different set of features for Postgres. First is tokenization. So your index is saved in tokens in here. So whatever set of keywords you send, it will create tokens for it, give it a integer value, and then it will decide how these tokens will be important or not in the indexing depending on your language. Then you have language awareness. In this one, you create your vector and your tokens for a specific language. If you have one phrase in English, it will be saved differently than if you have like a sentence or a set of keywords in Spanish. So when you create an index, you need to tell it, okay, this index is in Spanish, this index is in English, this is in Italian, and so on and so forth, because the binary representation of the tokens will be different. Then you have weight. You can also do this in Apache Elasticsearch, but in kind of a different way. Postgres is a relational database, so it's kind of easier to understand how things are working, but it's not in memory. That's kind of the disadvantage of this. You will go to disk to do this type of queries. So the weighting is from your index model. You want to tell, okay, the title is the most important part of in the search. The content is the second most important, and the subtitle is the third most important. So based on that, you will get the ranking and say this is as relevant for your query or not. Then you have the search operators. We do have those in Apache. The search operator will be like not like all the Boolean wildcards and things like that. Then you have ranking. Ranking will be calculated depending on the language that you set and your the weighting of your model. What you tell that, okay, this is more important or not. So that will affect your ranking. Then this one is something that is more specific to Postgres, and is in Postgres you have all the type of primitive data like integers, decimals, text, and so on. But also Postgres support JSON and binary JSON. So you can also use these objects to create your vector searches. So you will not only search in simple text, you can search inside of a JSON. There is a solution for this on Apache, but it's a little bit more cumbersome. And since this is kind of built in Postgres, you take it for free in general. So also you have two different type of indexes. And this type of indexes will depend on your database engine. So you have gene indexes that are good for a small amount of information, and his index that are for bigger data sets. So let's go to the example. So we're going to use the same application, but in this case, we're using Entity Framework for or vector search. This is a vector search, not Elasticsearch, but in the end, they are both full text search. So let's see how we create the data first. So let's see, create the vectors. So in here we have kind of the same idea. We get the services out of the application, and then we have the vector DB context. So let me show you what the context is. It's basically an entity framework context, nothing special on it, with a DB set. Also, let me show you the DB set. See, it's kind of a really simple class that we use for generic type of indexes. But in the Elasticsearch example with Apache, we kind of had a generic model for the indexing. And this model is one-to-one to our blog entity. It's basically the same object. The main difference is that we have this class, this property, which is a vector. This property is where we will calculate the vector out of these other properties and save it here. And when we search, we're not using these values, we're using the values here. So, okay, here we get the service. There are some other things that are interesting in the context. Let me show you. Let's go to the context. So in the context, you have a few interesting parts. First, that you're using the geolocation types. This is not for geolocation, but that actually is not only for including the geolocation types, it includes every secondary type in Postgres, in the Postgres connector. So it means that with that, you can use the type of columns that are vectors and things like that that are not included in the normal provider for entity framework. So to use this is important. Then we're logging the queries to the console. And another important thing here is that we are never calculating or index, or basically we're not calculating the vector manually. What we have is a computed column. So this computed column, you use the hasComputed_column method from Entity Framework, and it's an expression. So this is the expression that we are using. We're telling, okay, this vector is going to be a computed column, which will be the mix of the title, subtitle, and content. Being the title, it has the biggest weight, and then next one and next one. So this is more important than this one. And we're saying that the vector that we're creating is on English, and we're using this table and this column for it. So basically, it's a calculated column that is also going to be stored. You have the physical record that represents this vector. It's not on memory. So that's basically it. So let's run this one. And well, let me show you the sample data. So we created this data set here, kind of knowing the rankings from before to make sense out of them in the demonstration. So this will rank number one. Why? Because we're going to do two searches for the word adventure and for the word jungle. So some of the articles that of the blog posts that we're searching for, they do have the word jungle in the title, but it will depend how early in the title it appears to decide which ranking you will have. So here we know the rankings from before, so we can cross them from what we're getting from Postgres. So that's why I say them with the exact number that we will get for the jungle keyword search. So let's run this one. So this one on different of the other one that I showed before, this will include one more column, which is the ranking. So you can see how relevant is this for your search. So the concept will be the same. We will create a test data, and then I will do some like 2 different searches to show the ranking, and that we are not executing queries to our transactional database. So get the console already. Okay, so first let's create some vectors. So if we go to the blog section, we don't have any records here. So let's clear this. Sample vectors. So here you can see also the queries from Entity Framework. So here is the insert, and the vector is being calculated at database level. So now if we refresh here, this is the data that we have in our transactional database. And if we go to, this is not drawing completely. Let's see, how can we, well, let's close it. And let's open that again. Yeah. Okay, so while the Postgres administrator is starting, let's here clear the console and let's do a search. Let's go to Postgres vector search. Let's clear the console. And the first term that we're going to search is Django, because all of the blogs that we have in the database are about Django. And some of them are about cooking and programming. So okay, so these are the results. First, I want to show you the beautiful query that it created. So this is the Elasticsearch query. So it's good that Entity Framework is handling this for us. Let me show you the query also in code. So let's go here. And this query is kind of interesting. It looks a little bit more interesting than the one from Apache. So let's see, where is the query part? Here. Okay, so to query our objects, we get the service from our application, from the service provider. Then, my pgadmin is failing. Okay, it doesn't matter right now. So then this is the query that we are executing. And as you can see here, in the where we don't tell, okay, let's search in all over all the columns. So we're searching just over the vector. And for that, we are basically creating a vector with the search term that we have. And then we are comparing that to the vector that we have in the database. And the second interesting part here is that the ordering by, we ask the database, okay, create a ranking of the results. So it will be sort from the most relevant to the less relevant, which is something that is interesting here. And then we just present the results to the UI. So as you can see, let's order this. The first result that we have is the jungle's hidden treasure, which is 0, which means it's the most relevant because first the title column is the one with more weight. And as you can see here, the word jungle appears also the same as it appeared on the second record. But the position of the word inside of the sentence in the first result is earlier than in the second result. In the second result is in the end. In the third result is in the subtitle. That's why it's the third one. So depending on which language are you using and what's the position of the word in the inside of the sentence and the weight of the column, your ranking will be different. And then the last example of searching, let's search for adventure. So here you can see how the natural language processing is working. We search for the word adventure, but we know that the word adventurous comes from adventure because we have natural language parsing. So it's also a match for the search. Because as you can see, we don't have the exact word all the time. And also you can see how these give the ranking. This one is actually closer than adventures. And in both cases, the word is at the beginning. That's why they have rank 0 and 1. And in the last case, the rank number 2 is on, the word is on the last position of the title. That's why it's ranking with a higher weight. And here the lower weight is the closest thing to what we want to search. So again, there were no queries to our transactional database. So we're using the vector search for this. So let me try one more time to see if I can show you I want to show you how the vectors are stored. If my pgadmin decide to work. Let's see. I will put it on the screen. So maybe with the pressure of everyone looking, it will decide to work. And if not, maybe I can connect with dbbeaver, but I don't know how it will show the vector. This one I know how it shows it. So let's see which one is faster. Both seem a little bit slow today. Yes, it's taking longer than usual. But in the meantime, let's check if there is any question on the chat. So far, so good. Clear as water. And yes, none of my DB managers are working. Oh, here we have this one. Good, good, good. Okay, so let's check the servers. Let's check the databases. I'm using this one because I've done this talk a few times lately. All of them have the same record, so it doesn't matter which one we open. So here, let's go and check for the tables. And here you have the special types. That's why it looks like our special types or basically geolocational types, but they're actually not, in the sense that we need to include those types to include the vectors, because I think that you use vectors when you do geolocational queries also. And you can see the columns. This one is the vector that we have for searching. And if we check the data, you can see that most of the index is readable, the index object, but then we have the vector. And as you can see, the vector has part of the word and then a number, which is the vector information, and also the weight information. So it's not saved on a way that is humanly readable by humans, basically. You cannot make sense out of this exactly. And one other thing is that just for demonstration purposes, we have saved these 3 columns. But in general, if you're going to only use the vector for searching, you don't need them. You can calculate your vector in memory and just save it directly. In this case, it's because this is a computed column that is the mix of these 3 first columns. So, but if not, you can just save the index and then use the index for searching, because you will need to retrieve this record actually from your transactional database, which is not this one, it's the one in SQL Server. So that's basically everything for my presentation. In conclusion, we have seen that there are many ways to include search functionality in your application. The most traditional way will be using queries and like operators, but you will put that burden on your transactional database, which is something that you can get away most of the time. But with huge databases and with a lot of people searching, that will slow down your transactional database. So it's better to separate that task to a different server. We saw how easy it is to include different search engines. Basically, you include the client, and you have to make a process to create the index and update the index, and then to search the index. Well, basically 3 functions. And then you need to create your indexes, knowing what you're going to use, like which language are you going to use. For searching, maybe your organization is fully in English or fully in Spanish. And then you do something to parse those results and go and query your real database just for that one specific record. So that's everything for today, family. So if there are questions, you can write them in the chat and I will gladly try to answer them.
Yeah, I do have one. So is the Apache server or any of the Elastic server, do they can share resources in the same server of our application? Should we move them to a separate server? How is the cost, or how is that part, like, basically?
Yeah, basically the idea is, I will not, of course, you can technically put it on the same server. So, but you will share the CPU. What you want to use is a separate machine to not use the CPU from your transactional database. And imagine that you're using Instagram or Facebook. There is a lot of searching in there because you search for users, you search for a specific post. All of that can happen in memory in some different place. And then once you have the specific record, you go and do a query for that specific record. So you can have it in the same server or not. It's up to you how to distribute this, but the main idea is to not use the same resources of your transactional server.
I use a same server for different database, or you have to be a one?
No, you can use different databases and just have different indexes on your Elasticsearch server. one for database A, one for database B, or you can just mix it. There is no restriction on how you plan your indexing. If you want to search across all the databases, maybe you have this multi-tenant scenario and you want to search across all of them, you just create a single index for all of them. And if not, you create an index for each database.
Perfect. No, that would be all on my side.
Great. So I guess is that if there is an announcement, Javier, and if not,
No,
we're good to go.
basically just want to mention that NetConf 2023 is coming. So November 14th to the 16th with a lot of great talks there, great information. So keep tuned by that. And even before that, on November 9th, we will have Michael Washington. That's one of the Blazor guys that I always follow and look up to him. And he has a lot of great content. He has a site called Blazor, a website that I recommend to everyone, a lot of great articles. And he just released a new book on Azure OpenAI using C#. So we know that right now with ChatGPT, AI is in everyone's mind, and whoever is not trying to learn and use it in their application will get behind. So I definitely recommend this book. I already have it. I haven't finished it, but what I have already went through is really good. But either way, he will be giving us a talk about how creating Azure OpenAI applications in our next meetup in November. So please stay tuned for that. As always, thank you for joining in. And if there is no other question, we'll see you guys next month. All right, guys. Yeah, have a
We're
good
good to
day.
go. Bye-bye.
Yeah.
Take care.
Hey, thank you, Jose. Great presentation.